All right, in our last video, we took a look called the value of methods. We demonstrated the purpose of methods to increase the sophistication of a program without really increasing the complexity. So we have a program here. Now we're going to look at this in JavaScript. We have a program here that's about 15 lines of code long, and we want to keep this program about the same length, but make it more sophisticated. And to do that, we are going to tackle this part right here where we're taking a prompt for a user's guess. And the reason for that is right now, I can really type in anything when we're guessing. So we have a secret number of 8, and I could put in 10,000 as a guess. I could also put in -12 as a guess. I could even type in the word cat as a guess. And that doesn't really seem like it makes much sense. It shouldn't be. I should be allowed to do that, or I should get some kind of error message to tell me, well, that number's way too big, or you can't type in a negative number, or you can't type in the word cat. So let's make this program a little bit better. And the first thing we need to do is create what is called a method, or in JavaScript also called a function. So same idea. And you start by writing the word function, and you'll have to forgive me too as I figure out JavaScript again. We're going to define the name of this function. So we're going to call this getGuess, and put some parentheses there, and then define a region. So we are defining a function that is going to have some steps here, and we can use it down here. So what we're going to do is replace this prompt with getGuess, colon, and we're just going to hit return up here. And I think we had one other spot. We'll do it right here, and I know it'll be a little bit different message, but that's okay. So the first thing we want to do is just make sure that we can get this to work. So the idea is we can define a function, give it a name, and then call it by name in places where in our program, so that our program jumps over to this other block of code, runs those lines, and then when it's done, comes back. Right now, this is kind of silly because we only have one line here. But what we can do is add lots of lines of code here without making our main program any bigger. So let's see if this works. And again, because I'm still learning JavaScript, it might not. So enter a number. Let's see. Let's try our 10,000 and our -12 and cat. And let's try a couple other guesses. Oh, so it doesn't look like it's working because we're not getting any of those messages. Oh, wait. No, it might be. Hey, all right, it is working. So our program is working, except if you look at this, it says we took 6 guesses, but one of our guesses was 1,000, another was -12, another was cat. We even had some guesses that repeated. And for some of those, they shouldn't really be counted. We should say, look, that's impossible. You don't understand the rules of the game. Try again. So let's go up in this function and make it a little bit more functional. So first thing we might do is get a temporary variable up here, equals prompt. And before we return it, we may want to do some checks and find out, is this variable even a contender for a valid answer in the game? So for example, if temp was less than 0, if it's a negative number, that doesn't really make much sense. So we might put in a message here that says console.log, not a valid answer, must be positive. All right. And then what we could do is have the person try again. So equals prompt, try again. All right. Let's test this out, see if it works. So enter valid number, we'll try 10,000. Looks good. We'll try -12. And now we get this error message. Not a valid answer. Must be positive. Try again. What about -5? Still doesn't like that. Okay, how about 4? That looks good. 6. We'll do cat again. And then how about the answer 3? Oh, no, it doesn't. Oops. I never actually returned our prompt down here. So let's fix that. So we took that prompt out and made a temporary variable to store it. Now let's put the temporary variable back in the return statement. So what happens here is we are returning information back to the main program that called this method. So we take a little detour, we run these lines of code, and a return statement allows those lines of code to send information back. One piece of information, but send information back to the program by which it was called. So we're going to send back the temp variable, and again, let's try it. 10,000, -12, -5, -6, -8. Oh, how about 4? How about cat? And answer 8. Now, it says it took us 6 guesses. Let's go back and count them. 1, 2, 3, 4, 5, 6, 7, 8. Obviously is not counting all of them. When we were doing these negative answers, it was skipping the count. It was saying that those weren't legitimate. So in fact, 1,000 counted. That was our first guess. -12 did not. -5 did not. -6 did not. -8 did not. 4 counted. Cat counted. And 8 counted. And it still gave us 6. So something is going on goofy there that we need to fix. But it wasn't counting all those negatives over and over again. So that's at least a step in the right direction. Now, we are still allowing for really big numbers, and we're also allowing for text. That's kind of silly. In trying to fix the text, what we really got to do is find out if it even is an integer. And I'm going to have to actually Google how to find out if a number is an integer, because I've never done that in JavaScript. So let's take a quick detour. And I don't think you can see what I'm typing, but I just Googled JavaScript how to tell if something is an int. And it looks like there is another function called number.isInteger, so you can call isInteger on a value. So let's do this. We'll go back to the screen. And how about before we even get here, we'll say number.isInteger temp. And what we want to find out if it's not an integer, so if number.isInteger temp is false, so if it's not an integer, we'll put out a message, console.log, please enter an int, and we'll take a new answer equals prompt. Again, and I think I also know why we're running into an issue with our count. So we're going to solve that in a moment. But let's just see if this error handling worked out. Enter a number, 10,000. Please enter an int. Oh, so it doesn't like that. -12. Not a valid answer, must be positive. So that's good. How if we write cat? And that time it seems like it's working. Okay. So I think we're getting a couple issues here that are all competing with one another. So let's figure out why. Right now we have an issue where we're going through this function and we can enter a prompt right away. And if it's not an integer, we can enter another prompt, which then gets checked down here. So first, let's tie these if statements together with an else if. So if it is not an integer, it can't possibly be a negative integer. So there's no reason to be checking those 2 in a row. What was happening is could violate one rule and then still violate another before getting here. The other issue that we're getting to is that by doing the prompt here, we're not actually allowing us to recheck for if it is an integer. So instead, what we can do is use what's called a recursive call. So this method can call itself and start the process again. So instead of having a prompt here, we're going to say get guess and have it call itself. I'll do the same thing right here. So when we have a valid integer that is not negative, it will get returned. And if we get into this method and have one of those errors, we're going to call a new version of getGuess. And once a valid number is entered there, it will get returned to temp, which in turn will get returned down below. Let's try this again and see how it's working. Enter a number, 10,000. Please enter an int. So that tells me that this still is not quite working. what we could do is try casting it to an int in JavaScript. Let's see. I don't know if that's how you do a cast in JavaScript, so let's just check again. All right, how to cast to an int in JavaScript. Parse int. That's the one. So we are going to go back here and say parse int. I think what's going to end up happening is we'll end up getting a error when we try to type that in. So let's say 10,000, enter a number. So that was fine. -12, not a valid answer, must be positive. So that looks fine. -5, not a valid answer, must be positive. -6, must be positive. And let's write the number 8. And now 2 guesses. So all those negative answers didn't get counted. Let's try our text answer though. Cat, please enter an int. Dog, please enter an int. Fish, please enter an int. Let's try 5 and then 9. And there we go. 2 guesses. So it didn't count all those other ones, and it did handle the error correctly. Now, let's add one more issue. What about that 10,000? That seems way out of the range. So we're going to go back to our main program, and our maximum answer is defined right here, that number 10. But let's replace it with a variable called max. And we'll write var max equals 10. And then down here, we're going to send max to this getGuess method as what is called a parameter. So we are now asking the program to get a guess, but at the same time, we're giving it a parameter. We're saying get a guess, but use this piece of information to do your job. So when we define the function getGuess, we're going to say we've taken a variable called max, and we can have another else if down here that says else if max is greater than, or sorry, else if my temp is greater than max. That means that it's too big, and we need to get another answer. Not a valid answer, must be less than, or, well, saying must not be bigger than, be bigger than max. I think that's how we do that in JavaScript, adding things together. So let's try again. Oh, maybe you don't need var there. Maybe it's just max. Let's see. There we go. Okay, so we got 10. Let's do our 10,000. Not a valid answer, must be bigger than 10. What about 100,000? What about 80? What about 9? And what about 10? Now, the interesting thing is, it didn't seem to give me a problem when I said 100,000. So we'll have to figure out why that's the case. But it did give me 3 guesses. Yeah, so something in there went a little goofy. Now we'll have to figure out what. Must be positive, must not be bigger than 10. Let's try running this again. Enter a number, so we'll do 100,000. Not a valid answer, must not be bigger than 10. 10,000. Oh, and my page is reloading, so maybe that had something to do with it acting a little bit goofy. All right, well, we're going to take a pause there then. In the Java video, we did go through top to bottom, and here we pretty much got there too. But let me just end with this, that all of this code right here is being run in our main program here. Oh, there we go. Without having to put all the code there. So the value of a method is still that we can take code, put it somewhere, give it a name, and then whenever it's convenient, call it up. And this is something we've already been doing. For example, this method is an integer. It goes through some work, and there are lines of code that get run that perform a task for us, and I don't need to see the code that does that task. I just need to know that the task gets done and gets done correctly. So one of the things that we usually do when we define functions or methods is we go right above them, and we give them a block comment. So in JavaScript, you can put these a slash star, then a star slash, and describe what it does. So this function or method function takes a max range for an int, asks the user to enter an int from the keyboard, and validates that the int is positive, no bigger than the max, and an actual int. All right, so we just wrote about 17 lines of code, and we use those 17 lines of code twice in this program, but our program still remains only about 14 lines of code. So again, that is why we create functions. Any sophisticated program that you've ever used is functions, calling functions to break down this big complicated task into something that's pretty seemingly simple. All right, bye now.